Good morning. Am I audible?
Yes, ma'am. Good morning,
Yes,
ma'am.
ma'am. Good morning, ma'am.
Have you updated attendance list? No, after last update, I have not yet updated the attendance list. Okay, it will be updated sometime this week. So your mid semester is starting on 23rd. So before that, we need to finish lots of syllabus. Uh, Tomorrow, can I take the lecture? Tomorrow is a holiday, but is it possible to have the lecture, regular lecture? Please let me know. Any
मैम हम
problem?
सिलेबस से पीछे है क्या? सिलेबस किस
Uh,
बात चल रही है?
बहुत ज्यादा पीछे तो नहीं है, but I just want to finish it before. I mean, I don't want to take the entire uh, week before 23rd. I need to finish it 3-4 days before that. Monday से एग्जाम है.
यस मैम, मंडे से 23rd.
Okay, so tomorrow can we have a regular lecture or anybody has any objection with that? You can tell me, no problem. We can take it later also, but please let me know. Okay, I'll ask you the same question towards the end of the lecture. We can decide that time. You can think. Let me start my sharing. Acha, I am not sure if I shared the last lecture notes. I think I just remembered I might not have shared. I'm not sure. I'll share together today. Okay. So this is the last lecture. We were talking about equilibrium. Okay, equilibrium of rigid bodies. Then we talked about supports. So how if it is a hinge support in 2D, if it is a hinge, if it is a roller, one reaction. If it is a hinge, then two reactions. And if it is fixed support, then there are three reactions. Okay. So we will try to solve some problems like that. So then again, condition of equilibrium, summation of forces equal to 0 and summation moment equal to 0. Then we talked about how to draw a free body diagram. Okay, so to draw a free body diagram, so again this free body diagram will topic will is recurring. Okay, every chapter we will need this creation of free body diagram, and you will learn something new about it every time. Okay, so here what we learned is that first you need to detach the body from the entire support. Okay, all the support, and then you see how many loads are acting. Then you have to add the self weight, and then the wherever there are supports, you have to replace them by appropriate reactions. Okay, so this is what we saw last class. And then one or two examples we spoke about how to draw a free body diagram. So one of this I had asked you which is the correct one, and this factor also. Okay. Then here we were here equilibrium of a rigid body in two dimensions. Okay. So again in 2D and 3D equations are similar. In 3D the equations increase instead of three equations there are six equations. That is the difference. So we will come to 3D after some time. But in case of two dimensions, there will be three equations. Okay, summation of fx, summation fy, and summation of moment. So this moment, summation of moment at some point A. Okay, so this is point A. But instead of point A, you can take summation of moment at point B also. Okay, or basically you need to find out three reactions. So you can use this moment at point A equal to 0, moment at point B equal to 0, and summation fx equal to 0 as well. So we need at least three equations. You can use these three. Basically, we need to solve for three unknowns. if we need to solve for three unknowns, Ax, Ay, and this B, reaction at B, then you can either use these three equations, or you can even use summation Fy equal to 0 and these three. So when we come to the example like this, it will be more clear. Basically, the point I am trying to make here is that you need three equations to solve for three unknowns. Whatever is the easiest and quickest way to solve this, that we will follow. So let me take some examples like that. What we have here. Okay. So last lecture we saw some problems, right? We just draw the. We were just trying to get what is the free body diagram. So this problem in the last lecture we saw how to draw the free body diagram. Okay. So now what I want to find out is determine the components of reactions at A and B. So here what is the reaction and here what is the reaction. So that actual values you need to find out. Okay. So first thing would be creation of free body diagram that we already saw how to do that. Okay. So what is this fixed train has a mass of 100 kg. Okay, so the 100 kg and this into 9.81. So that is kilonewton. In kilonewton, you are writing that. And then again, this 2400 kg. So 2400 kg, if you convert it into kilonewton, you will get this value. Okay, so again, SI units we are using. So it's better if you convert everything to either Newton or kilonewton. So now how to solve this? So either what you can do is if you take summation of moment at A equal to 0, summation of moment of all forces at A equal to 0, okay, then these two forces AX and AY won't produce any moment at A because they are passing through A. Okay, so that equation you will just have one unknown B. So you can quickly find B. Okay, so there is one strategy like this. Okay, suppose you take summation of moment at A equal to 0, summation of forces of all moments at A equal to 0, then you take summation Fx equal to 0 and you take, so summation of moment at A equal to 0 will give you reaction at B, Then if you do summation Fx equal to 0, then this is known, so only one unknown is there. So this will give you Ax, and then again, if you do summation of Fy equal to 0, this will give you Ay because all the other forces are known. Okay, so this is one strategy. You can even take um, other approach. Any three equations you can solve, but this is the quickest way to solve the problem. Okay, so let us this you can read later when you go back. Let me just jump into solving the problem. Okay. So I want you to do everyone summation of moment at A equal to 0 and find the value of reaction at B. Find the value of reaction at B. So if we do summation of, I'll do the first one for you. Okay, if we do summation of moment at A equal to 0, so let us take one force. So this is 23.5. This at this point, so it is producing a clockwise moment. This force at this point, okay, clockwise is negative. Okay, then you know force into distance. Distance is 6 meter. Okay, so this is for this force. Then you again take this force. This force, this is the distance, that is 2 meter. Again, this force at this point clockwise. So minus 9.81 into 2. Okay, ये दो forces हो गए. Now these two forces won't produce any moment at A because they are passing through that point. Okay. Then this one, RB, RB at this point. So it is like this. So it is anti-clockwise. Okay, anti-clockwise, so positive. RB into 1.5. Okay. So RB you can find out. Any doubt you can ask me. Any confusion you can ask me. Chalo, calculate this fast. This is a one-step solution. Roll number 91, Srushti. I want an answer from you. Srushti, you there? Roll number 91. "92, are you there? 92. Okay, Raghav has sent me one answer. 91, 92, 93. Any of you? Please don't be virtually present in the class. Otherwise, you will face problem in the exam. You won't be able to perform properly in the exam. "94, 95. 94, 95 are absent. Okay. Chalo. So the answer which I got from few of you was 107.08 kilonewton. Okay, so ये हो गया RB. Now you want to find AX and AY. So simply if you do summation Fx equal to 0. Okay, so X direction में there are two forces, this one and this one. So if you do summation Fx equal to 0, this gives you AX plus RB equal to 0. So AX is minus RB. So AX is minus 107.08 kilonewton. So what does this tell us that initially the direction of AX was like this. Now the AX is coming as negative. So AX is actually in this direction. Okay, or you can just say 107.08 kilonewton and the direction is like this. Okay, here I will just write the direction is like this. Okay, then if you do summation Fy equal to 0, so summation Fy equal to 0, then how many forces are there in Y direction? 1, 2, 3. Okay, so AY minus 9.81 minus 23.5 equal to 0. So AY, okay, already 33.31. Somebody has given the answer. 33.31 kilonewton. Though AY is up. Okay. Sorry. So this is how you can find the reactions. Okay. So this is your one answer. Sorry. Okay, I wanted to highlight this, but somehow my pen is not allowing. Anyway, so this is your answer. This one, and that one. RB, AX, and AY will be your answer because they are asking determine the components of reactions. Determine the components of reactions at A and B. So you have to find how many reactions are there at A and B. How much ever reactions are there. Now let us quickly go to the other problem. This was the other problem which we saw in the last class. We had already drawn the free body diagram. Okay, so I am not going to elaborate on that. So the free body diagram in the last example, last class, we have seen, and the problem can be find reactions. find reactions. How many reactions are there in this problem? How many reactions? How many unknown reactions can you see in this problem?
Two reaction, ma'am, and ME.
B, add B
Three.
and E.
Yeah, EX, EY, and ME. Okay. So here again, you need to find three equations. Okay. So one way to go about it. Okay, one way to go about it. I mean, you can, if you take summation fx equal to 0, this will give you ex. Because x direction में there will be some component of f and that will negate your ex. Okay. If you do summation fy equal to 0, you will get ey. Okay. And if you do summation of moment at e equal to 0, you will get me. Okay. So you just need to do these three calculations and you can find that. So now the first thing here you need to find this angle. Okay. Then only you can go about this equation. You need to resolve this 150. Okay. So that theta, if you take this theta here, the same theta will be here. So that theta you can take it as tan inverse 4.5 by 6. Okay. Same theta can be here and then you can find Ex. So 36.87 degrees. Okay. Then you can find this equation fx. This you can write Ex plus 150 sin theta होगा ना. So sin 36.87 equal to 0. So Ex value will come as negative. That means your Ex is towards the left. Okay. Then you can simply do summation Fy equal to 0. This will give you Ex. If you do summation Fy equal to 0, so Ey minus 150 cos 36.87 minus 1, 2, 3, 4. 20 into 4. Okay. So Ex and Ey values, you can calculate all the three values. Okay. Ex, you are telling me it is come as 90. Okay. So Ex is equal to minus 90 kilonewton. So this is like that. Okay. Ey, you are telling me 200. Okay. And it is not negative, right? So it will be up. Then moment at E, this thing, ME 180 kilonewton meter. So this is coming as positive, right? 180 kilonewton meter, it is coming as positive, right? If it is coming as positive, it is positive, then you can just write it like this. You can write it is anti-clockwise, or you can write in full also, anti-clockwise. Okay. So in exam, whatever time you are taking, even in a lesser time, you need to find out these reactions. Okay. So please practice this. I'll take one more practice example. Let me just see what I have here. Okay, before that, let me introduce one concept to you. Okay, so there is this concept of degree of indeterminacy. This we will come back one more time on this when we talk about trusses. But here at this point, you should uh, be aware ki what is this. So when we talk about trusses in some chapter 8 or 9, that time we will talk about this one more time. Okay. So degree of indeterminacy of a structure is number of unknowns minus number of equilibrium equations. Okay. So in 2D, how many equilibrium equations we have? We just discussed in 2D how many equilibrium equations we have. We have 3. Summation fx, summation fy, and summation of moment at any point. Okay, some point. Or sometimes you might use the summation moment at 2 points and only fx. They are variable, but only 3. Okay, so let us in from this definition. If I ask you, okay, so from this definition, if I ask you, okay, these two are hinge supports. Okay, these two are hinge support. So iska degree of indeterminacy. Degree of indeterminacy, I am just talking it as DOI.
One time.
1. Yeah. Because there are two reactions here. So 4 minus 3, that is 1. Okay. So suppose this is a fixed support and there is a hinge. Then
2.
5 minus 3, that is 2. Because 1, 2, structures. Okay, these two are indeterminate because number of unknowns are more than the number of equilibrium equations. So we are lagging behind the equilibrium equations. Agar hame in this case, if I somehow get one more equilibrium equation, then I will be able to solve the problem. Solve the problem in the sense I'll be able to find the reactions. In this case, if there are two more equations available somehow, then I will be able to find the reactions. So these two are indeterminate, you can say beams, or indeterminate structures, you can see. So usually what in our case we will be solving some problem like this. Here, what is the degree of indeterminacy for this problem, whatever I have drawn? There is a roller, there is a hinge. 0. Okay, that means this is determinate. Okay, this is determinate. You can even talk about this. If this is a fixed support, cantilever, we can say there is no support here. So these two are determinate structures. So these are in our scope. This is not in the scope of your syllabus, this indeterminate structures. Okay. But at least you should be able to know what are determinate and indeterminate structures. So whenever we want to solve for indeterminate structures, just 1 minute, let me complete. Whenever we want to solve for indeterminate structures, that means we want to find the unknown reactions. That time more equations are needed. Here one more equations is needed. Here one more equation is needed. So those are called as compatibility equations. Okay. So in your higher semesters, you will learn more about that. But for scope of this syllabus, we are going to focus only on determinate structures. Yes, there was some question.
Ma'am, I didn't understand flip the unknown, ma'am. That is rotation.
Okay. You understood this much part ki if number of unknowns and number of unknowns is more than the number of equilibrium equations, then the structure is indeterminate. That this part you understood?
Understood, ma'am.
Okay. So here you are having problem. You are saying this fixed one or this
Second,
one?
ma'am. Second
Okay.
structure.
Okay.
5 minus 3.
यहाँ पे this is hinge. and this is roller. Okay. So at hinge there are two reactions, 1, 2. At roller there is one reaction. Okay. So our DOI, number of unknowns 1, 2, 3 minus number of equilibrium equations. Number of equilibrium equations in case of 2D will always be 3. 3 minus 3, that is 0. That is why
Not
this
this,
is
ma'am.
0.
Upper one, ma'am.
Okay, upper one.
Yes, ma'am.
So
5
यहाँ
minus
पे
3.
it is, this is 1, 2 and 3. So again the DOI is 3 reactions. Number of unknowns are 3. Number of equilibrium equations is 3. 0 only, right? Whenever there is a fixed support, you have 3 reactions.
ऊपर वाला समझ में नहीं आ रहा है जिसमें 5 आ गया है मैम.
ये वाला,
रिएक्शन 4 तो हो गया. इसमें ये 5th वाला घुमाने वाला नहीं है समझ में.
ओके ओके. So जब भी there is a fixed support, whenever there is a fixed support, there is 1, 2, 3 reactions. This you understand? Whenever there is a fixed support, we have 3 reactions.
No, ma'am. To understand, ma'am.
We discussed the
Third.
same in the last class also, right? Just 1 minute. Whenever there is a fixed support, this is a fixed support, okay? This one. So it is like this. मतलब यहाँ पे it is fixed. So whenever there is a fixed support, there are 3 reactions, 2 forces and 1 moment. Okay. So ये fixed support, whenever there is a fixed support, there are 3 reactions. So that fixed support, it is represented like this. So whenever you take, ये ऐसे दिया रहेगा, so this is fixed. Okay. It is
Okay.
usually represented like this. Whenever it is like this, this is hinge. Whenever you have a support like this is roller. Okay.
Okay.
So
One
ये जो
reaction.
support है, ये fixed है. So there are 3 reactions. यहाँ पे there is hinge, so there are 2 reactions. So 1, 2, 3, 4, 5, total 5. And number of equilibrium equations, in case of 2D, it will be only 3. So this
3.
is 2. Understood? Or there is some more confusion?
Understood, ma'am.
Okay. Okay. So where was I? So I was telling you कि in first year, your engineering mechanics syllabus, we will be considering only this determinate structures. So means आपका जो number of unknowns है will be always be equal to the number of equilibrium equations. Okay. That way, you will be always able to solve the problem completely. Like you solve the problem in the sense, find out the unknown reactions. This one, in this case, we need one additional equation because there are 4 unknowns and 3 equations only. In this case, we need two additional equations. So those additional equations usually come from the conditions of compatibility. So that is again, it is not that the problem is not solvable. There are few advanced methods to do to solve these problems to find out the unknown reactions, but you will come to know about that in the higher semesters. At this point, you should be able to find out if I give you a 2D problem, whether it is determinate or not. Okay, whether the problem, whether the structure or whether the beam is determinate or not, that much you are expected to understand. Okay. So statically indeterminate reaction. So you can say the structure is indeterminate, or we can even talk about the similar terminology, statically indeterminate reactions. Okay. Reactions are said to be statically determinate, number of unknowns equal to the number of equilibrium equations. This topic might be a bit confusing for you. Okay, I'll come back to this. Okay, I'll come back to this slide after some time. I don't want to confuse you. Let us focus. This I'll just take after some time. I don't want to. Okay. So while we are on this, let me take 1 or 2 problems. So it will be easier for you. This one, I need to get a. because if I talk about that constraints, you might get confused. So let me tell you something else first, then we can come back there. So let us say कि we are talking about determinate problem, or you can say determinate reactions. That means you are able to find out all the reactions. Okay, so we will talk about this. So again, in this, there are many types of loads also. You remember in the last class we talked about a structure, and then there were beams, there were columns. So this is a fixed support. This is beam. This is column. Okay. I was telling you about this. So there is a roof here. Okay. Then there are beams. Then there are columns. So there is a slab. I hope you understand this terminology. At least slab in any house where you are sitting right now. So there will be a slab. So यहाँ पे there will be loads on the slab. Then the loads will be transferred to the beams, and the load will be transferred to the columns. Then it goes to the foundation. Okay. So we talked about this. Anyway, not to get you overwhelmed, so yeah, there will be some loads on this slab. Okay, so for our simplicity, okay, we classify that loads. Okay, so one is a point load. Point load. Okay, or you can even talk about it as concentrated load. So it will be just represented by a point. Okay. And the unit will be kilonewton, or the unit can be Newton. So second, then there will be uniformly distributed load. इसको हम बोलते हैं UDL also, uniformly distributed load, UDL. So this is usually represented like this. Okay, and this is suppose it is W, so it is kilonewton per meter or Newton per meter. So if this is some length, anyway, let me just first talk about units. Okay. So it will be UDL, and it will be other way of representing it is like this also. Uniformly distributed over the some length. Okay. So like this also, again, this will be W, kilonewton per meter or Newton per meter or Newton per mm, something like this. Okay. Load per unit length. Okay. Then there is third kind of load, that is uniformly varying load. इसको हम बोलते हैं UVL. Okay. So this you can represent like this. So here the intensity is 0, here the intensity is W, something like that. Okay, so this ordinate will be W, or your UVL can be, any other kind. So it can be like this also. कि right side में it is 0 and here it is W, or it can be like this, any combination. Okay, so these are some physical cases. Okay, so here the ordinate will be given as W. Okay. So this point load, okay, just to give you some physical significance. So यहाँ पे if there is an almirah, a very heavy almirah, so this will introduce a point load. Okay, if some almirah is kept, this uniformly distributed load, so due to the dead weight, dead load, so your brick, suppose this is made up of some bricks. Okay, the slab is made up of some bricks. So this will be the load by these bricks will be something like that. Okay. And this UVL, this can also be, any kind of loading, usually wind or something. The distribution is like this. Okay. Anyway, again, these are the topics of your higher semester, but at least you should know which kind of load is coming. So in your syllabus, this was there, this is there. We don't usually ask you this questions on UVL, but you should know the difference between UDL and UVL. Okay. Now let us move one more step ahead. Now I want you to suppose I give you very simple example. Okay. Uh, so this is a beam. Okay. There is a roller here. Then there is a hinge here. Suppose there is a point load here and there is a point load here. 2.7 kilonewton. This is 70 kilonewton. यहाँ पे भी एक डाल देते हैं. Say 2.7, same point load, and then you need the distance. 0.6 meter. 0.6 meter. यहाँ से, sorry. From here to here, 0.9 meter. From here to here, 1.8 meter. Okay. Now, this is a simply supported beam with overhang. Why I am taking overhang? ये जो portion है, from here to here, it is an overhang portion. Okay. So this is just the terminology which we are using. Now you find the reactions. Okay, you have to find the reaction. Simple approach. You can take summation fx, summation fy, and summation of moment at some point. So यहाँ, if this is A, this is B, okay, and you can draw another figure. Okay, I am drawing on this only. So this is a roller. So one reaction AY. This is a hinge. So BY and say BX. Because it is a hinge, there will be two reactions. Okay. Now, suppose if you just take summation fx equal to 0, what is the value of bx you get? If you take summation fx equal to 0, what is the value of bx you will get?
0.
Yeah. Because there are no other forces in the x direction, bx is 0. Okay. Now, suppose you take summation of moment at b equal to 0. Okay. Or summation of moment at a equal to 0, any point. Okay. So this ay won't produce any moment here. So there will be only one unknown in that equation. So you can quickly find by. So if you do summation of moment at a equal to 0, this will give you by. Okay. Then you do summation fy equal to 0. This will give you ay. So please calculate the values. If you have any confusion, you can stop and ask me. Okay. So we are just trying to find the reactions now. Okay, AY is 42.87. BY is 30.53. Okay, Shubham has given a correct answer. What about others? Okay, is there anyone who doesn't know how to solve this problem? You can feel free to ask me. Okay, I'm just assuming that by this point you have got a hang of it. Basically, you just have to sum all moment of all the forces at A equal to 0. Okay. Let me just explain to you one more time. Some students are having doubts. Chalo. So I am just talking about if I talk about this equation, okay, moment at A. Now I will keep on talking about one force. Okay. So this is the first force. This force is passing through A, so it does not produce any moment. Okay. Now let us talk about this force, 70 kilonewton force. 70 kilonewton force at A. It is going like this. So clockwise. Okay. Clockwise. So I am taking minus sign. 70 into distance is 0.9. Okay. Let me remove this. Now this by it is like this, anti-clockwise, so positive. You have to move from by and this, like how that moment is being produced. Okay, so like this, anti-clockwise positive, by into distance, zero point 0.9 plus 1.8, so 2.7. Okay, the third force, this force, 2.7. So again, clockwise minus. Okay, so this 2.7 into distance. So this was distance was 2.7 plus 0.6, 33. Sorry, 3.3. Okay. Then this is again 2.7. Okay. So again, it is producing clockwise moment. So I am taking it as negative 2.7 into. Okay. So 3.3 plus this entire distance now you have to take. Because moment is at A, the force is here. So this distance between the point of application of the force and the point at which moment is being taken. So that is 3.9 equal to 0. So this you will get By, and Ay is then simply for the third one. So this is minus 70 minus 2.7 minus 2.7 plus, I'm so sorry.
मैम AY शायद 44.87 होगा मैम.
There might be calculation mistake. ठीक है, plus AY plus BY. इसमें we know BY from the top, so only AY is remaining. So you can calculate AY. 44.86 आ रहा है AY. 44.86 kilonewton and BY I got as 30.53 kilonewton. Okay? आप 42 बोल रहे थे या 44 बोल रहे थे? आई एम गेटिंग 44.
44 होगा मैम, क्योंकि AY प्लस BY 70 प्लस 2.7 प्लस 2.7 होगा ना 75.4.
Okay, so I am hoping कि everybody got this. Any more confusion? 55 तो नहीं आ रहा है. अच्छा, anyway, let me move forward. मुझे एक और I want to finish one more example. You can go and check these calculations. Two, three students are not getting the correct answers. You can go back and check. Okay. I'll just take one more example like this. We talked about UDL, right? UDL. Okay. So suppose, am I audible? I am having some network issue. Am I still audible?
Yes, ma'am.
Yes, ma'am.
Not audible, ma'am.
Some network issue from my side. Okay. Can you hear me now?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
Yes, ma'am.
Some issue was there from my side. How much time we have? Acha, let me at least introduce that problem. You can do the calculations at home. Acha. Let me see if I have that here. Okay, I don't have any problem like that. Let us try to find some example. We can just talk about it. Okay. So suppose this is a beam. Okay. Let us take very simple beam. This is again simply supported. Okay. One end hinge, one end roller. You can talk about simply supported. So ये जो suppose this is 2 meter. This part is 3 meter and this part is 2 meter. And from 2 to 3 meter, there is a UDL. Okay. And at here, 1 meter, there is say 20 kilonewton load. And this UDL is 10 kilonewton per meter, 15 kilonewton per meter. Acha. Now you have to find the reactions. Please remember, we are just trying to find the reactions now. So this, suppose this is A, this is B. So this can be AY, this can be AX, and this can be BY. Achha. Now the new thing here is this UDL. This UDL, this is 15 kilonewton per meter, and it is distributed at this 3 meter span. Achha. So what is usually done is we consider कि this इसका effect is at the center. इसका effect is at the center, so this you replace it by a point load. So this will be the center, 1.5 meter, 1.5 meter, and you replace it by a point load. Okay, this will be a point load, and that point load intensity will be 15 into 3. So that will be W into L. Anyway, let me draw it one more time here. So whenever there is a load, this is W and this is L. Okay, so you can replace this by a point load. You can replace this at by a point load acting at the center. This is W into L, that will be point load, and this will be acting at a distance L by 2. L by 2. Okay, so this 45 kilonewton will be acting here at the center. Okay, so you can just replace it. Just for the simplicity, I am writing it here. Okay, so this is 45 kilonewton. Okay, and it is acting here. Suppose this is 2 meters, so this will be 1.5. And then you have this is 1 meter, right? Or यहाँ पे we already have a UDL 20 kilonewton. Okay, so this is 1.5 meter. This is 1 meter. So the UDL problem you have solved into a problem where there are 2 point loads. Okay, where there are 2 point loads. So this problem you know how to solve. Now there is AY, there is AX, and there is BY. So you forget about the top problem. Okay, that problem we have converted into a problem with 2 point loads. So this is 15 is the 45. So again, you can just take a summation of moment at A equal to 0. That will give you BY. If you take summation Fx equal to 0, this will give you Ax. And if you take summation Fy equal to 0, that will give you Ay. Okay. So instead of solving this problem, we are solving now this problem. Okay, it is not necessary always to draw this diagram. Okay, the bottom diagram again. You can simply even make all the calculations in your head. So here you just have to remember that this UDL will be acting at the center, will be replaced by a point load acting at the center. So this you can solve, right? We just solved a problem like this, 2-3 point loads. So simply you can just do these equations and solve the problem. So this solution I will give you with the notes. Okay, nothing new in this. Again, tomorrow can I take the class at 9? I'm asking you again the question. Is it possible? If not possible tomorrow, then give me a slot on Wednesday, because I can't miss any more classes. Naman is there.
Yes, ma'am. Yes, ma'am. Ma'am, you can take class tomorrow.
We can take? Okay, okay. So we will meet tomorrow at 9. Okay, I will finish this topic then. Okay, thank you.
Thank you, ma'am.
Okay, I will end the meeting. I will share both the notes today after some time. Thank you.